Hi everyone, so today we will go to the triple integral. Okay, so page 75 of your module, you can refer to your module. So for this triple integral, it is mainly used to find the volume of a solid. As its name says, triple integral, so you will see three integration symbol here, and this one will be 1, will always be 1, and this one dv stands for the volume. So for this triple integral, okay, we will do it by using three types of coordinate system: Cartesian, cylindrical, and spherical. So for this class, I will focus only on the Cartesian coordinate, which means that this dv will be represented by dx, dy, or dz. Okay, so this is the combination of dv for Cartesian coordinate. So we will see one example. Okay, so we will be clearer on how to use these triple integrals to find the volume of a solid. So I need you to refer to page 75, example 2.18. In this example, you are required to use triple integrals to find the volume of a solid which is bounded above. So in this section, you will see many wording, okay, from the question. For example, like this one, this is bounded above. Bounded above means, okay, the top of the solid, okay, is covered by, okay, it's covered by this one. Okay, this is the question. Okay, so the solid, okay, is bounded above by this plane and below by region R in the xy plane. Okay, so below it is covered by this region, okay, which is in the interval of x 0 to 1 and y 0 to 2. So you need to draw this structure out firstly. Okay, so this is the plane. Okay, I hope you already used to the technique on how to draw a plane. Okay, you can refer to your module or you can refer to this step. If you have been given this one, remember, put the number on the right hand side and xyz on the left hand side. So, and your job is to make this part to be 1. Okay, in order to transform the 4 to be 1, you need to divide 4. When you divide the right side with 4, you have to divide the left side with 4 as well, like this. Okay, so simplify this one. Okay, the intersection point on axis x, y, z will be 2, 4, 4 respectively. So this is axis x, this is axis y, and this is axis z. Okay, so this is how you draw the plane. And for this region, okay, 0 to 1, 0 to 2, okay, so you have to draw in this way. X is from 0 to 1, y is from 0 to 2. Okay, it is a square shape and you extend it out. So this one will be the solid that you need to find its volume. Okay, so you can double check with the questions. The question says that the solid is bounded above, means that the top of the solid is covered by this triangle plane, and below it is covered by region x 0 to 1 and y 0 to 2. Okay, so this one is the solid. So we have to use these equations. Okay, first of all, we have to choose projection. Projection means where you want to look at this solid. Okay, if I choose the xy projection, it means that I look at this solid from top, okay, from the z-axis. So you put your eyes here. Okay, when you put your eyes here, basically you will see a square shape here. Alright, square shape here. So this is what you see. Okay, so this is a very easy shape. Okay, when you need to define their interval, okay, the x will be from 0 to 1, 0 to 1, and the y will be from 0 to 2. Okay, 0 to 2. So for the dv here, if you remember, I'm going to represent the dv by dx and dy. So I need to define their interval. Okay, so this will be their interval, and last will be dz. Okay, For the dz, you have to imagine yourself sitting inside this solid, and z is the position when you refer up. Okay, just imagine when you look up. Okay, you look up and you will see a plane. You will see a top which is covered by this triangle plane, and when you refer down, you actually see a flat surface which is located at z equals to 0. So my dz will be from 0, because when I refer down, I see a flat surface. I see my floor, for example. Okay, and the position is z equals to 0. And when I refer up, okay, just imagine you lift up your head, okay, and you will see a plane, okay, and this is the equation of the plane. Okay, so now we have to put all the intervals here into our triple integral. Remember, here is always 1, and for the dz, okay, it will be from 0 up to this one, and for the dy here, 0 up to 2, and dx 0 up to 1. Okay, so this is how you define the interval, okay, for triple integral used to find the volume of the solid. Okay, so you integrate as usual. Okay, I hope you don't have any problem on integrations. Okay, so dz, okay, you will get this one, and you will get this one, and now you have to integrate with respect to y. So this whole thing is actually a constant, so I combine them, I top up with a y when I do the integrations, and this one become y squared over 2, interval from 0 to 2. Okay, so when you replace this one here, okay, you'll find that the whole thing only contains one variable, which is the x. Okay, so for this one, you can actually press your calculator in order to get the answer, which is equivalent to 4 units. Remember, you cannot press the calculator, okay, when that equation contains more than one variable. For example, this one, x and y, you cannot press calculator for the answer. Okay, you can only press calculator when the whole thing here only contains one variable. So if you are not sure how to use calculator, okay, to perform or calculate the integration, you can check, okay, the video in YouTube. There are a lot of video teaching you how to use the calculator, okay, in order to calculate the integration question there. Okay, so next, let's try one more example, okay, which is example 2.19, page 76. Okay, 76. So in this example, you have to use the triple integrals again to find the volume of the tetrahedron bounded by plane. Okay, and this tetrahedron is bounded by this plane, okay, and this plane, and this one. Okay, so you have to draw each of it one by one. So I will show you, okay, how to simplify this one in order to get a triangle plane. Okay, next we focus on all these plane. Okay, when x equals to 2y, okay, you can simplify it, or you can rewrite it to be this way. So I think you have no problem, okay, when you need to draw these equations. This is 2D equations, so which means that it is a straight line, okay, a straight line. And when you extend this straight line in 3D, imagine this is your y, this is your x, this is a straight line, and when you imagine it in 3D, okay, it is a plane, something like this. Okay, it's a plane, something like this. Just extend it in the z position, and after that is the plane. X equals to 0. Okay, x equals to 0 is here. Okay, and z equals to 0. Imagine, okay, you have a plane. Just imagine the plane like a piece of paper, and it is located at height z equals to 0. Okay, something like this. So when you combine it, okay, it actually becomes like this. This is your plane, okay, triangle plane, and this is the equations. Okay, x equals to 2y, and you have the bottom. Okay, this bottom part is actually covered by this one, z equals to 0, and for the x equals to 0, it covers the side at the back, okay, which is the one that I label by cross. So this is the volume. Okay, the whole thing will be the volume that you need to find is volume. Okay, so this is the equations. Again, you need to choose the projection. Okay, here I choose xy projections. So I will look at this solid from the top. Okay, when I look at this solid from the top, basically I see this small triangle at the bottom, right? So I will draw this small triangle into the y and x. Okay, you will see this thing. Okay, this is the small triangle here. Okay, this is a small triangle. Now I need to define the interval for my dx and dy. Okay, so this will be similar like you perform the double integrations, okay, in order to find the area in the previous sections. So here I choose the vertical strip technique. Okay, vertical strip technique will be easier because I no need to split the area into two parts. Okay, so for vertical strip technique, okay, this when you move this vertical line to here, okay, up to here, okay, your x value will be 0, and when you move it to the maximum point, and you will stop here. Okay, so you need to know, okay, or you need to determine what is the value of the x at this point. So for this one, you need to perform simultaneous equations. Okay, so this line is represented by these equations, and this line is actually a part of the triangle plane, right? This one, and this line is located at z equals to 0. So when I replace this z equals to 0, I will get x plus 2y equals to 2. So this one will be the equation of my straight line here. Okay, solving the simultaneous equations, at the end I will find that my x will be 1. So you can try it out yourself, check, okay, whether you get 1 or not. So my dx will be from 0 up to 1 here. Next is to define a dy. Okay, so for dy, you have to put yourself inside here. Okay, when you refer down, you will see this line. Okay, right, and it is x equals to 2y, so its y will be equals to x divide 2. You see, x divide 2 is here. Just move it, okay, because I need to define the y. Okay, I need the y, so I need to move the 2 here. Next, you refer up, you see this line. Okay, so you refer to this equation. Again, I need to move all the number to the left side and leave the y at the right side. Okay, so this one will become x minus 2 divide negative 2 here. Okay, so this one will be the interval of my dy. After we settle the dy, we need to define the interval for dz. So we need to look at the 3D solid again. Imagine yourself sitting inside, okay, the solid, and when you refer down, when you look down, you see a flat surface, okay, which is located at z equals to 0, right? So again, your z will be 0, and when you refer up, okay, you will see a surface which is a part of this triangle plane. Okay, so I will use the equation of this triangle plane here, and at the end I put them into my triple integral, okay, their interval, and you have to ensure that, okay, the arrangement of this dz, dy, dx must be tally with the interval here. For example, this dz, okay, will be from 0 up to 2 minus x minus 2y. Okay, and for the dy, you put their interval here, and for the dx, you put the interval here. Now we do the integration one by one. First of all is the dz. Okay, you will get this one, and after that you perform integration with respect to y. This is a constant, so I insert 1y minus y squared over 2. You put the interval here, so here you still need to do it by manual method. And after you get this one, okay, you can press your calculator, okay, or you can choose to do it manually. Okay, it depends on you. Okay, so when you press calculator, at the end you will get 1/3. So I prefer you to use calculator because it shortens the calculation time, and also it ensure, okay, you will get the correct answer. So the answer will be 1/3 unit cube. Okay, the cube stands for, this answer means the volume. Okay, so this is about the triple integrations by using Cartesian coordinate. And of course there are more examples, okay, in your module. You can look at it. Okay, I will give you a few tutorial, okay, so you can try it at home, and I will explain to you the solution as usual. Okay,